So for my problem, I got a projectile problem where the first section we are spending trying to figure out what the maximum height is and at what angle that will be. So the position of the projectile was given by r of t is equal to the initial velocity multiplied by the cosine of the angle times t, I for the position for the component of x, plus the initial velocity sine of the angle multiplied by t minus 1/2 gt squared to take into account gravity and the initial speed for the upwards direction. Now, intuitively we know that if you fire something directly upwards at 90 degrees, it is going to be the absolute highest that you can get with that initial velocity, because all of that velocity is applied directly in the y component. So we know that the angle is going to be equal to 90 degrees, so we can then solve for what the height will be, what the maximum height will be. So we can take the derivative of this. Actually, let's cancel this section first, because the cosine of 90 is going to be 0. Multiply all of this is going to give you 0. So the derivative of r of t, r prime of t, is going to be the initial velocity times the sine of 90, as that's just a constant, dt, minus g of t, because the 2, when taking the derivative, will cancel with the 1/2 dt. This is your new formula for the velocity, and we know whenever velocity is 0 for a projectile fired directly upwards, then it will be at a max height. So the first time anyway. So 0 is equal to initial velocity sine of 90 minus gravity times t. So we know that sine of 90 is going to be 1 based on the unit circle. So we now have, after we move over gt, gravity times time is equal to the initial velocity. Now we just need to solve for t. T is going to be equal to the initial velocity divided by gravity. That is the time at which the height will be at the max. So now we plug this time back into our original equation, excluding the cosine, which is still just for an x position, and the angle will still be 90. So now we are left with r of v initial over gravity is going to be equal to the velocity initial times t here, which is going to be v initial gravity, minus 1/2 g times v initial over gravity squared. When we square this, we are going to get v, or rather when we simplify this down, we get v initial squared over gravity minus 1/2 g times v initial squared over g squared. One of the squares will cancel with the g, leaving us with v initial squared over g minus 1/2 v initial squared over g. These are the same, therefore we can say this is all equal to positive 1/2 v initial squared over g. And that is going to be the maximum height for this projectile.